come now to the next point, the vibration damper. So we have 6 vibration damper on the CHP, and come on. So we have 2 vibration damper on the engine, on front of the engine. So that means here at the stamp in front of the engine, one on the left side, one on the right hand side, and as well this is a steel plate and the rubber in between, and then a steel plate again. The steel plate is mounted to the frame and to the holder of the engine, and the rubber is in between. So check the rubber always that they are still connected with the steel plates and the rubber is not cracked. The same we have underneath the alternator. So we have on the alternator 4 pieces with one here, one there, and on the other side 2 as well. So this is the sliding frame from the alternator, and here again we have the steel plate, the rubber in between, and steel plate. With the steel plate here coupled to the frame and rubber in between. So check the rubber, that the rubbers are not damaged or cracked or broken. Okay, oil cooler. So important, we have to check the oil cooler sealing and replace the oil cooler sealing. So we have here the oil cooler. The oil cooler is mounted, let me go quick back. So the oil cooler is mounted at the engine with the cover, the oil cooler, the gasket, and the O-ring. The oil cooler, so the oil pump push the oil through the oil cooler cool down the oil temperature. So that means here this is the water what is flowing through the cooler. We have a bigger one here. So the water is running through the heat exchanger of the oil cooler and cool down the oil. The oil runs through the oil cooler, and then one pipe goes back to the centrifugal filter. You push the filter, so start to rotate the centrifugal filter. The other part of the oil runs through the additional filter, get cleaned, comes back, and get used in the engine system again. That are the O-rings what must be replaced, and we have to check the cover gasket. So this is the O-rings what separate actually the water and the oil from each other. So if this O-ring got broken or damaged or something like that, then water can go into the engine oil, or engine oil can go into the water. So if we get water into the engine oil, we will damage the oil, and if we get oil into the water, we will damage the water and the water cycle. So, but more worst is if we get water into the oil. If we have water into the oil, we can get the engine damage on the system. Let me quick. So the oil cooler must be done every 10,800 operating hours. Or for sure, if you can find a leakage on the gasket outside, then we have to check that earlier. And the oil cooler by themselves, if we have dirty coolant water, then it could happen that the oil cooler by themselves, the thin lamelles inside get dirty and the heat cannot transfer properly anymore. That means we get a high oil temperature, and that can cause problems on the engine as well. And if the oil get overheated over a longer period of time, the oil quality drops, so the oil get damaged, and out of that we can get further damages on the engine. Okay, cylinder head valve clearance. We have to check the so that's the clearance of the cylinder head valves. That's the inlet valve, IV 1, 2, 3, 5, and so on, and the outlet valves. So we have to check that every 3600 operating hour, that we have the right tolerance and measurement. More details you will get from the document work description DC12. So the DC12 is Scania engine document. I assume that everybody know that, otherwise you can read that in the description, or we do a separate video on that. So we have here 2 valves and here 2 valves, and the clearance of the valve here of the arm must exactly adjusted over that screw and adjusted to the right value. So first check, and then if the valve clearance is different or not on the right value, you have to adjust. So open the nut, adjust the bolt, so that that arm can be adjusted on the angle, and you have to follow exactly the points of the Scania DC12 description work. Okay, let's go to the next step here. The replacement of injectors. So injectors, the injection system is a special design from Schnell, as we know already, and a bit of the way. We have our high pressure pump supplies the high pressure pilot fuel to the rail. From the rail goes to the injectors. So the injectors is sitting here in the cylinder head. We have the supply line of diesel or pilot fuel goes into the injector. So, and the injector should be replaced. Should be replaced every 7,200 operating hours. We have a instruction document for that, how to replace the injectors. Now we're using second-hand injectors in some of the plants in Japan. It could always happen that there maybe must be replaced earlier, but if the injector is working well, we always can see. I will do that on the video where we discuss about the injecting system and control timing, so the injecting angle and the pulse width, how we can see that the injector get problems not only on the cylinder temperature, on some other values as well. So we can replace the injectors at 7,200 operating hours, but in some cases I had in the experience that I had some systems running with new injectors with operating hours up to 10,000 operating hours. So it all depends on the quality of the diesel, number one, the quality of the diesel. How good is the gas quality, because this will have an impact on the injectors by themselves as well. So this is it's difficult to say how long it can survive, but yeah, out of my experience, I have systems running with one injector set longer than 7,200 operating hours, but Schnell recommend to replace them by 7,200 operating hours. If we can focus a little bit more on the details about that, we can reduce maintenance cost and keep the let's say the injectors for longer time in operation. But this depends on all other factors around that. So it's gas quality, it's the diesel quality, how we use it from the tank. For example, I like to mention one thing. Every time when we refill the main diesel tanks, over time there's in diesel or in other fuels, there's always some small dirt or particulars in the tank, and that gets settled over time on the bottom of the tank. So that means if we're running the tank almost empty and we refill the tank with new diesel, we're starting to mix the dirt up again. So the dirt goes back into the whole diesel, and the engine will suck the little bit more dirty diesel into the injection system, and that can force more problems on the injector. For sure, we have different filter in place. We have a 10 μ filter, we have a 3 μ filter, and 2 other filters after the common pump as well. But still, sometimes there are so small particulates that they get problems on the injectors. So I recommend one thing first. Don't refill the main tank during operation of the CHP. I recommend first thing is stop all CHP for at least 1 hour at a time, or at the time when you refill the diesel tanks. Minimum 1 hour. It will help that your injector lifespan will increase. Number 2 is, if we run a different design, so for example, if we have 2 diesel tanks, let me move in a bit. Okay, let me explain a little bit. So if we have 2 diesel tanks, and we always use only one for the supply for the CHP. If there's number one tank is empty, then we swap over and switch over to tank number 2. During the time when the CHP is running of tank number 2, we refill number 1. So the tank in number 1, the dirt, what get mixed with the new diesel, have time to settle completely to the bottom of the tank until we use them again. And then if the tank 2 is empty, we swap over to tank 1, and now all the dirt is settled on the bottom of the tank, and we're sucking only nice, clean, good diesel out of the tank. And if you're working always like a parallel system, oh no, not just a parallel system, a swap over system, first use tank 1, then switch over to tank 2, refill tank 1. We have done testing on that, or I have done testing on that, and the result was that actually we operate some of the injectors up to 12,000 operating hours, and that shows me that we cannot filter all small particle out of the whole diesel system, and as well, what I mentioned earlier, that we can get water into the diesel tank as well. So if we mix them up by refilling and mix up water in the diesel tank, this water goes into the injection system and can damage the injector or pump and injector as well. So I recommend to operate on a double tank switch system. But if we don't have this option, minimum stop the engine for 1 or 2 hours at the time when you refill the tank, that you not get all the dirt into the system. I can do a video more in detail about that as well later on. The cylinder head, we can see here a drawing. So we have here the forward flow pipe to the injectors, what must be removed, so we can get the injectors out. We have here the return flow pipe where the diesel goes back. That's the electric morph. And then we have that clip what holds the injector in the cylinder head. Here we can see the injector sitting in the cylinder head. Here we have the cooling system of the nozzle of the cylinder. Here is the clip what holds the injector down on position. That is the forward flow pipe, and here the return flow pipe. So here we can see some picture of inside of the injectors. We spoke already about the injector system, the conveyor system. So we have the electric valve control, the ramp up pressure profile, and the operating pressure up to 1000 bars, the injection pressure up to 2500 bars at the end of the day. So there's only some points to repeat again. Here we have a cut of the cylinder head. We can see here the copper housing, that's the cooling slaves, and you see here the cooling slave. So the injector is sitting in here. This copper housing actually is in the water cooling system. So here, around here, the water cooling system of the cylinder head runs through and cool down the injectors. It's special made because of the low pilot fuel amount. We need additional cooling that we increase the lifespan of the injectors. In a pure diesel system or engine, you don't need this cooling system, or you don't have this copper sleeves in there, because you spraying a much bigger amount of diesel, or you inject a much bigger amount of diesel through the injectors. That means the diesel will cool down the injectors by themselves. In our case, as a dual pilot fuel CHP, the amount is only very small, and that means we don't have any cooling, or not much cooling from the diesel. So we need additional cooling on the injector nozzles that do not get overheated. So we have here on top a Sega ring. It's like a spring ring what holds that copper slave down. So there is a dip here and here, so the ring clamp the copper housing down, and the O-ring to seal, the O-ring is sitting here to seal that the water cannot go up to the cylinder head. If we have a problem with the O-ring, what prevent that the water from the engine jacket goes up. If the water goes up, so if the O-ring is damaged and the water goes up, the water goes into the into the top of the cylinder head, will go into here, and then it can go into the engine oil. So we have to prevent that, and if we replace the injectors, we always have to ensure that that rubber seal is tight and the clip here, the Sega ring, is in place. On each cylinder head, I'd like to mention that as well, we have so each cylinder head have their own temperature sensor. The temperature sensor on the 6R20B engine is built into the cylinder head. We have here a cut the cylinder head. We have here the injectors, valves. So this is a thermocouple type K sensor. This sensor goes into the cylinder head. So that means there is a hole drilled into the cylinder head, into the bottom of the cylinder head. That means we can, if you open the cylinder head, you cannot see the end point of the sensor. The sensor goes into the cylinder head, into the steel, and measure the temperature some millimeter above the bottom of the cylinder head. So each cylinder have their own cylinder temperature measurement. So, and here quick to explain why sometimes the temperature is different. There are different reasons. Some of the holes what get drilled into here, because it's very deep, a deep hole, thin and deep hole. That different cylinder heads have different levels where the temperature sensor is in closer or not that close to the bottom of the cylinder head. That could be a reason. And as well, the water, the cooling water of the engine goes through the cylinder head and start from cylinder 1 to goes to cylinder 6. That means the coldest water will be always in cylinder 1, and then the temperature will increase until cylinder 6. So usually you will have a ramp of the cylinder temperature, but still it depends where is exact the position on the cylinder head of the temperature sensor. So we measure the direct temperature here in the combustion chamber, or not the direct, but almost direct temperature in the combustion chamber, to compare to some other systems where, for example, at gas auto systems, they all measure temperature of the cylinder in the exhaust gas. So they measure in all outlet of the exhaust gas the temperature. So totally different story. That's why we can see here the direct combustion temperature in the cylinder head. Now, I mentioned already that we can have different temperatures between the cylinder temperature measurement. So one is the cooling, pass heat the sensor is from cylinder 1 to the cylinder 6. That means the cylinder 1 is get colder water than the cylinder 6. Then the sensor position and the hole, what I mentioned already, and as well for sure the spring. That spring must be press the sensor to the point in, to the end point in here. If the spring is loose, the sensor maybe is not on the right position, and then it measures wrong. Here we have a picture of injector nozzle. So this is only the injector nozzle is only the front part of the injector. So a very small piece. See if I put a, no, I don't, sorry. Come back. Yeah. Okay. So we have the nozzle. The fuel comes into the channel here. That is the needle inside. So the needle gets lifted from the pressure and open the bottom part so that the diesel can get down and spray out on the nozzle tip through the holes. So the quality of the ignition depends on some point of the injectors. So the injector actually, we can have cooking on the nozzles. So we get bad combustion or dirt burned here directly on the nozzle, and then you get particular on the nozzles get black here and close the nozzles. So this can make a problem on the injectors. And the next one is that the whole nozzle get worn through all the operations, so the gaps are not working very well, and the nozzle are the gaps in between the nozzles or the clearance is too big, and then the nozzle doesn't work anymore or properly. And then we had the next one, so that the needle in the nozzle get actually stuck, so jammed. So if it's overheating, then the needle, what usually goes up and down to open the holes to inject the diesel, get stuck in the nozzle. If this happens, then one of the cylinder temperature drops, and we recognize that on the cylinder temperature. So impact on, so if we get problems on the injector, the problem can change the injector timing. That means if the nozzle doesn't work properly, then the the point when we spray the pilot fuel or the diesel in the combustion chamber may be changed. That means the time change, and we're talking about microseconds, where we like to get the diesel into the combustion chamber to ignite the biogas properly. So if this is changing, the timing, that means actually the angle, the injector angle, if they are changed, the combustion of the engine will change, and through that the efficiency will change. As well, if the nozzle gets on, that means we need maybe more fuel amount to spray in to get the same combustion as before. If one of the injectors, so for example, if we have 6 injectors and one of the injectors is not working well, that means if one is not working well, then the other 5 have to take over the load what is missing from injector 1. That we will have the same situation if we have to replace an injector, but we replace only maybe 2 injectors. So that means I have 2 new injectors and 4 old injectors in the same system. The 4 old injectors will spray less diesel in because they are older than the 2 new ones with the same pulse width. I will go in much deeper in that later on. It's only to understand. It's very important that we not only that we always focus on that all injectors should get replaced. Special if the injectors already are very old. If we get a problem with new injectors and we replace one, that's not a problem at all. But if we have injectors already running, for example, with 5, 6, 7,000 operating hours, then we should always replace not only 1 or 2 what make the problem, we should replace all 6 to prevent exactly that negative impact here. This negative impact, if 2 injectors works different to the other 4, then we can get problems on the different cylinders, because the cylinders are working on different injector timing, fuel amount, and the load between the cylinders will change. So what I mean with that is, if the load, if we have 250 kilowatt, for example, then the 250 kilowatt of load is splitted in between each cylinder. So one part is cylinder 1, 2, 3, 4, 5, 6. If one cylinder is not take over the same part as the other cylinder, that means the other 4 or 5 cylinders have to cover the lower load of this one cylinder. And on the other hand, means the other cylinders get hotter. So always keep that in mind. We will go into that a little bit deeper. That's only a part to mention that quickly. Okay. Oh, that's one of a very, very important point. Measure compression, so, and pressure loss test. So that means that we can measure, or we should measure, the compression or the pressure loss, or both, as a kind of indicator to prevent problems in advance. So if we measure it, we can analyze if we see a problem coming up in future. We can see if one cylinder is not that good as another one. It's almost the same what I mentioned earlier with the injectors. So it's the same thing. So if one of the cylinders is not working with the same load as another one, that means lower load, then the other one have to take over the other load to get the sum of the 250 kilowatt. So this measurement is very important and should be done always either if we have some problems already, or if we have to replace the injectors anyway, because we measure directly where usually the injectors are mounted. So we have to take the injectors out and can do the measurement. So if we have to take the injectors out to replace it anyway, so we can do the measurement from cylinder to cylinder almost at the same time, and we will save a lot of time and keep a proper record and can see in advance if we get problems on some cylinders. The compression and pressure loss measurement should be usually done at 7,200 operating hour. That's the time where we replace the injector anyway. And this gives us an indicator if we have problems on the either on the cylinder head valves, so that we have a leakage at the valves, that the compression is not that high as it should, or we have problems on the piston or piston rings, so that will drop the compression as well, so that the pressure gets down to the engine block. There are two documents important. One is a PDF that is actually the instruction how to measure, and then we have an Excel file that shows you what is used to add all the information of the measurement to give you a proper report if we have any problems on the cylinder. So I go now deeper into this document to make sure that you understand the document and why is it important to fill the document with all values to get the best report and the understanding about each value. Okay, let's jump in. So with our compression measurement and pressure loss tool, we can indicate the current conditions and prevent problems for the future in advance. So if we fill out the document properly, and please fill out always all values what are required, and that we get a proper result out of this report. So at the end of the day, this report will show us the conditions of the engine, and so focusing on the cylinder head valves and the piston rings. And it's much easier if you know what comes in future. So if we know in advance which cylinder maybe get the problem in future, or what has changed since the last measurement, we can easier indicate in which direction we have to move and organize our spare parts. So please try to follow the steps, go through the document and get all information into this document. I will now go a little bit deeper into this document to show you the different values and why they are important. So first of all, we have to fill out the information about the client, watch CHP, date, etc., operating hours, and the rated power where we run the CHP. Then we have all the cylinders here listed. In your case, it's actually either a 5-cylinder or 6-cylinder CHP. We have the information about the operating hours of the cylinder head. So in case we replace one cylinder head, that we fill it out, that we know at the next time which or how many operating hour the cylinder heads have on the counter. Then we need, if we do the compression measurement, we need the start speed RPM. So the compression measurement will be done on the instruction. Follow the instruction, and important, look on the RPM of the starting speed, because the starting speed, if the starting speed is different, it will give you a different result on the numbers of the compression. The same will be with the oil temperature. For example, if the engine is cold, then the starting speed maybe will be lower, and the combustion or the combustion pressure will be different than it is warmer. So always please fill out all the values here and go through step by step. Measure the clearance of the cylinder head valve, inlet outlet valves. Important, the coolant temperature. Important, the oil temperature. What I mentioned already, different temperatures in the engine give you maybe a different result. So if we like to compare an older measurement with a newer measurement, I like to see, okay, why the measurements may be different. Okay, if the oil temperature are different, that can force different outputs or measurement values. Then our target of the inlet valves is 0.45 millimeter clearance space. The outlet valves is 0.7 millimeter in cold conditions. That means when the engine is cooled down and stand forward. And then we measure the compression ratio and put that into the Excel sheet, and the Excel sheet will show up if we have any problem on the cylinder head valves or on the piston rings. So for the testing, let me move a little bit out of the way. For testing, we have two tests. We have one test is the compression measurement. For that we use that tool. Please check the instruction what I have in the folder or at the file, how to go through the separate steps. It shows up exactly the process where we have to focus on how we do the testing and how we go through the separate steps. We need the adapter that we can measure on each cylinder at the time when we took the injectors out. And as well, the pressure loss, we can do it with a separate tool. It's all in the instruction what I will send to you, or you should have it already. So let's go to the next one. Here again, to do the compression measurement, it's important, very important, to follow all the steps one by one. But the most important thing is that we have a full charged starter battery. The starter battery quality and voltage depends on the engine speed. If the engine speed is different, the measurement result will be different. So important that we record and mark the speed, and that we make sure or ensure before we start that the starter batteries are full and in good conditions. Follow the process, then we will get a proper result here. And in this case of that measurement, we can see that here the cylinder 2 and the cylinder 5 in the compression measurement are out of range. So, and with the pressure loss measurement, again we get the problem on cylinder 2 and cylinder 5. So the most damaged one is on cylinder 5, and so that means we have to focus on cylinder 5 and cylinder 2. All the others are looking actually good, are in the range, and this helps us to prevent future problems. If we run the engine like that for further some 1,000 operating hours, we can get more and more damage. It's the same like a problem on the injectors. So again, if this cylinder 2 and the cylinder 5 does not work properly, the other 4 cylinder has to take over the load of this cylinder. So for example, all cylinders should actually provide almost the same load. If 1 or 2 cylinders are below, that means the load here will be lower, or they cannot produce the same load. That means all other 4 cylinders have to take over the missing load of this damaged cylinders. And if we run further with that, that means maybe 1 or 2 or all of the other 4 cylinders can get damaged as well, because we're running overload on the 4 cylinders because the 2 cylinders are underload. So we have the 100%, the 100% is the 250 kilowatt, and that gets splitted into all cylinders. So if 1 or 2 not working well, the other 4 have to take over the load of the other 2 what is not working well. So again, please do this measurement regularly, and we can find out and reduce costs in advance to prevent future problems on that. Okay, let's go to the next. Please again, I always like to mention it again, if you have any question to this, we can do a separate video directly on the measurement step by step, and if there is any question or misunderstanding, let me know. Please let me know. It's very, very important that we get everything nice in place. So next step, we going to the Conrad and main bearing. So we have to replace every 7,200 operating hour the Conrad bearing, and at 14,400 the main bearing. Here on the Conrad, I like to mention some points. So one thing is, we have instruction here from Scania for the DC-12 engine. That's the engine for the 6R20B, what we use in Japan. We have the cracked Conrad. That means the Conrads are cracked here with the opposite side. So this cracked one. The cracked one, if we replace them, the screws have to be tightened with 50 Newton meter first, step 1, and then plus 90 degree. So first we tighten it with 50 Newton meter, and then we turn the screw and tighten additional 90 degree. Important on that is the cracked surface area must be oil free. So we're talking about that area and that area, so here and here, and the opposite side must be oil free if we put the new bearing in. The Conrads and the cracked parts, so the cracked shell on the other side, always have to fit together. So if we take them out, mark it with the cylinder number that we put the same direction back to each other. Otherwise we can get problems on that. Important that screws of the conrads and actually on the main bearings as well. The screws can only be used once. If you open the screw, you have to replace the screw. So always, if you replace the bearings, you have to replace the screws. The screws special made is like a torque yard bolt, and you can only use it once. If you take it out and like to take it again, that will not have the same pressure and hold and stability of the bolt anymore. So only use it once. Very important. If one of the bolts get loose, we will get immediately issues on the oil pressure and then damage on the engine, and that could be at the end of the day very, very, very expensive. Let's go to the next one. So we have here, for example, the conrad and the main bearing actually looks the same. Sorry for that, this in German, that's the only picture what I found quickly. The main bearings, the main friction bearings have to be replaced every 14,400 operating hours. So here we have the conrad bearings. We can see here the bearings brand new bearings, and that's bearings, used bearings. This one still looks almost okay. If you can see scratches and damages of H2S sulfur content, then we have to replace it anyway. But the bearings are not the most expensive part of the things. Here we can see some wear damages on the bearings. At the point when you see the first layer is off, the first layer is a gray layer. Underneath there is like a copper, let's say this looks like a copper layer underneath. The one here, yeah. So that scratches. These bearings have to be replaced. It's worn, so that's very, very important that we replace it. Here we still, again, we have the pictures of the H2S content on the bearings. This looks like that. It's like small spots, so that the different layers get loose already, and that will be very important to replace as well. Okay, again, quickly, the conrad bearings must be replaced every 7,200 operating hours, or minimum must be checked. I recommend on the 6R20 turbo compound engine to replace it every 7,200 operating hours if it's not looking new again. But important, the screws must be replaced as well. Okay, and let's jump to the cylinder head.